Reasons we got interested in AI from the very beginning is that we always viewed our mission as a timeless mission. It's to organize the world's information and make it universally accessible and useful. But as information has grown in scale and complexity, the problem has gotten harder. So we always knew we needed to have a deeper breakthrough to make progress.
I've worked on AI my whole life because I've always felt it would be the most beneficial and consequential technology for humanity. Human beings in our society would have 5 senses, and the world we've built and the media we consume is in those different modalities. So I'm super proud and excited to announce the launch of the Gemini era, a first step towards a truly universal AI model.
The Gemini approach to multimodality is all the kinds of things you want an artificial intelligence system to be able to do. And these are capabilities that haven't really existed in computers before.
Traditionally, multimodal models are created by stitching together text-only, vision-only, and audio-only models in a suboptimal way at a secondary stage. Gemini is the multimodal from the ground up, so it can seamlessly have a conversation across modalities and give you the best possible response.
Gemini is our largest and most capable model. It means that Gemini can understand the world around us in the way that we do and absorb any type of input and output. So not just text like most models, but also code, audio, image, and video. What's amazing about Gemini is that it's so good at so many things. As we started getting to the end of the training, we started seeing that Gemini was better than any other model out there on these very, very important benchmarks. For example, each of the 50 different subject areas that we tested on, it's as good as the best expert humans in those areas.
It's very rare that you can work on a technology at a foundational level and it simultaneously can impact all our products.
We created a family of models that can run on everything from mobile devices to data centers, each of which is actually best in class.
Gemini will be available in 3 sizes. Gemini Ultra, our most capable and largest model for highly complex tasks. Gemini Pro, our best performing model for a broad range of tasks. And Gemini Nano, our most efficient model for on-device tasks.
We want to provide the best foundational building blocks, and then we know developers and enterprise customers are going to figure out really creative ways to further refine our Gemini foundational models, and the potential's almost limitless.
So at Google, there's this healthy disregard for the impossible, and that has oriented us to be both bold and responsible together. As these systems become more capable, all of those capabilities also raise new questions.
We have to think about what it means to have an image be a part of, for example, the input. Because an image might be innocuous on its own, or text might be innocuous on its own, but the combination could be offensive or hurtful.
Safety and responsibility has to be built in from the beginning. And at Google DeepMind, that's what we've done with Gemini.
We develop proactive policies and adapt those to the unique considerations of multimodal capabilities. We then do rigorous testing against those policies to prevent the harms that we've identified with approaches like classifiers and filters.
If I were to look at the foundational breakthroughs in AI over the past decade, Google has been at the forefront of many of those breakthroughs. And I think Gemini continues that rich tradition.
It's been an enormous sort of monumental engineering task, which has been, very challenging, but also very exciting.
I have been at Google for quite a while, and the reason I'm here is really I believe in the company's mission. And I think Gemini is a great step in that overall mission.
We end up with a world that has more knowledge and that people have more access to information that otherwise would not be available to them.
That's what excites me, the chance to make AI helpful for everyone, everywhere in the world.
So now what you're about to see is Google's multimodal capabilities. One of the things that Google has talked about previously was exactly how Gemini would be focused mainly on multimodal stuff, and that they would increase the capabilities of the multimodality. This example that you're about to watch clearly demonstrates how advanced Google Gemini's multimodal capabilities truly are.
some ideas. Let's start. All right, testing Gemini. Here we go. Tell me what you see.
I see you placing a piece of paper on the table. I see a squiggly line.
What about now?
The contour lines are smooth and flowing, with no sharp angles or jagged edges. It looks like a bird to me.
What if I add this?
The bird is swimming in the water. It has a long neck and beak. It is a duck.
Yes.
A duck is a type of waterfowl in the family Anatidae. Ducks are closely related to geese and swans. The duck appears to be blue. This is not a common color for ducks. However, there are some breeds of blue ducks. These are typically not as common as other duck breeds. It is more common for ducks to be brown, black, or white.
Are you sure?
What the quack? I was just talking about a blue duck, and now you're holding one. It looks like blue ducks are more common than I thought.
Would this float?
I'm not sure what material it's made of, but it looks like it might be rubber or plastic.
What if I tell you it's making a squeaking sound?
Oh, if it's squeaking, it's definitely going to float.
Nice.
It is a rubber duck. It is made of a material that is less dense than water.
Can you teach me how to say this in a different language? And give me a few options. Ooh, can you explain how to pronounce the Mandarin one? Is it Yazi?
Yazi is pronounced with a first tone. In Mandarin, there are 4 tones, which are essential to distinguish the meaning of words. The first tone is a high, level tone.
Oh, okay.
The duck is in the middle of the ocean. There is no land nearby for the duck to rest or find food. It is unlikely to find ducks here naturally.
Okay, based on what you see, come up with a game idea. Oh, and use emojis, please.
How about this? We can play a game called Guess the Country.
Sure, let's do it.
Clue 1. This country is the home of the kangaroo, the koala, and the Great Barrier Reef.
Oh, that's easy.
Clue 2. This country loves football and has won the most men's World Cups in football history. You are trying to get me to find the paper ball under the cup. I accept the challenge. The cup to the left.
Nice.
I know what you're doing. You're playing rock, paper, scissors.
What do you see now?
The fingers are spread out to look like the wings of a butterfly.
What's this?
Big ear and barking mouth. A dog.
Sweet.
The coin should be under the right hand.
I don't know.
The coin is in the left hand using a sleight of hand technique to make it appear as if the coin has disappeared. Both objects are round and flat.
There you go.
Both are food. The orange is a healthier choice than the cookie. Citrus can be calming, and so can the spin of the fidget toy. They are both examples of popular toys that have been enjoyed by children and adults alike for many years.
Give me some ideas for what I could make with this.
I see pink and green yarn. How about a dragon fruit? Or how about a green cake with a pink heart?
Okay, how about these colors? And maybe show me some animals.
Okay, now I see blue and pink yarn. How about a pig with blue ears? Or an octopus? Or a bunny with a pink nose?
Ooh, I'll keep those in mind. Which way should the duck go?
Going left leads to a duck, which is a friend. Going right leads to a bear, which is a foe. It is better to make friends than foes, so the duck should go left.
Smart choice.
This is a picture of a crab.
That's right. Is this the right order?
No, the correct order is Sun, Earth, Saturn.
Based on their design, which of these would go faster?
The car on the right would be faster. It is more aerodynamic.
Which looks more fun?
The one on the right, because it has a loop.
What do you think this person might be saying?
How about a woohoo?
Ooh, I love that.
I see you're drawing a guitar. You've added an amp. Now it's an electric guitar. We can make some seriously loud music now. Given that you added drums, how about some 80s hair metal? Alright, I see you've added a palm tree to the drawing. Change it up with some beachy vibes.
What movie are they acting out here?
I think they are acting out the famous bullet time scene from The Matrix.
Ooh, nice. What do you think might happen next?
The cat is going to jump to the wall and stick the landing. It's going to be a perfect 10. Oh, and it's a miss. It looks like it was just a little too far away, but don't worry. The cat is a natural athlete and it will be back up there in no time.
Okay, I've got one more for you. Describe the drawing I made.
It is a simple line drawing of the constellation Gemini. You did a good job of capturing the beauty of Gemini.
Nice. That's it. I think we're done.
Now it's time to take a look at one of the most important things regarding Gemini, and that is, of course, the benchmarks. Now, you can see here that these are the benchmarks compared to GPT-4, as it is the next level in large language model. But currently, GPT-4 has been surpassed in nearly everything by Gemini Ultra. We can see that in the general capabilities, the MMLU, that Gemini Ultra received a 90% and GPT-4 received an 86.4%. If we scroll down to the reasoning tab, you can see that on the big bench hard, on the drop, Gemini Ultra achieved better results, although maybe only marginal. It did achieve better results in this category. The only category it didn't was the Hella Swag, where it achieved a 87.8%, which is of course still very respectable. If we do look at the math benchmarks and the code benchmarks, we can see that on the GSM 8K, Gemini Ultra received a 94.4% compared to GPT-4's 92%. On the math tasks, which include challenging problems, including algebra, geometry, pre-calculus, and others, it achieved a 53.2% compared to GPT-4's 52.9%. And on the coding with a human eval, it achieved a 74.4% compared to GPT-4's 67%. And on the natural 2 code, it achieved a 74.9% compared to GPT-4's 73.9%. So overall, Gemini Ultra does surpass GPT-4 in 7 out of these 8 categories, which does make it right now the very best large language model that you can use in the AI space. So now we have the multimodal benchmarks, and these are the multimodal benchmarks in which Gemini and GPT-4 were compared against. What's really incredible was that across every single benchmark on this page, Gemini Ultra surpassed GPT-4's previous capabilities. So you can see that across all of the image benchmarks, Gemini achieved 59%, 77%, 82%, and 90%. And in all of these categories, it does surpass GPT-4. And this is, of course, GPT-4 with vision, which is the latest model that can analyze images. In addition, since GPT-4 doesn't have video, what they've done is they've compared Gemini Ultra to DeepMind's Flamingo, and you can see that it achieved a 62.7% compared to DeepMind's score of 56, which is, of course, the same model that the same company did before, but it just shows a decent improvement. In addition, what is also very interesting was that we did see that even in audio, Gemini Pro outclasses OpenAI's Whisper v2 and Whisper v3, which shows us that Google Gemini is currently a truly state-of-the-art large language model / multimodal AI system. Now let's take a look at Gemini's ultra impressive capabilities in terms of reasoning and truly understanding what a user needs.
Here you will see a demo of Gemini's multimodal reasoning capabilities to understand and reason about users' intent, use tools, and generate bespoke user experiences that go beyond chat interfaces. Let's say I'm looking for inspirations for a birthday party theme for my daughter. Gemini says, I can help you with that. Could you tell me what she's interested in? So I say, sure, she loves animals, and we're thinking about doing something outdoors. At this point, instead of responding in text, Gemini goes and creates a bespoke interface to help me explore ideas. It's got lots of ideas, it's visually rich, it's interactable. Now, none of this was coded up. It was all generated by Gemini. Gemini uses a series of reasoning steps, going from broad decisions to increasingly high resolution of reasoning, finally getting to code and data. First, Gemini considers, does it even need an UI? Is a text prompt best? Okay, this is a complex request that needs lots of information to be presented in an organized way. Gemini then tries to understand if it knows enough to help. There is a lot of ambiguity. I didn't say what my daughter's interests are or what kind of a party I wanted, so it had asked a clarifying question. When I said, we're thinking about an outdoor party and my daughter loves animals, Gemini reasoned it had enough information to proceed. But it made a note that there was still ambiguity about what kind of animals, and this is important, and what kind of outdoor party. Next is a critical step. Gemini writes the product requirement document, or PRD. It contains the plan for the kinds of functionality the experience will have. For instance, it should show different possible party themes, some activities, and food options for them. Now, based on this PRD, Gemini tries to design the best experience for the user's journey. It thinks that the user will like to explore a list of options, but will also want to delve into details. It uses this to design a list and detailed layout that we saw earlier. With this design, it writes the Flutter code to compose the interface out of widgets and write any functionality needed. Finally, it generates and retrieves the data needed to render the experience. You can see it filling in content and images for the different sections. Ah, farm animals. She would like that. Clicking on the interface regenerates the data to be rendered by the code it wrote. Ooh, I know she likes cupcakes. I can now click on anything in the interface and ask it for more information. I could say, step-by-step instructions on how to bake this. And it starts to generate a new UI. This time, it designs an UI best suited for giving me step-by-step instructions. I want to find some suitable cake toppers for this. Show me some farm animal cake toppers. At this point, Gemini again decides to create a visually rich experience. It generates a gallery of images. Notice the drop-downs at the top. It decided that maybe it should help me explore by showing different options. Sheep sounds interesting. I know she likes that. And now it helps me pick sheep cake toppers. These look great. This is going to be a fun birthday party. I hope you saw a glimpse of what Gemini is capable of. I'm really excited about what's possible here. This is such an interesting time in AI, and I'm excited to be part of this.
Now let's take a look at Gemini's ultra multimodal capabilities in terms of helping someone with their homework.
As a parent, you may have to help your kid with their homework. I've certainly had to. Here's where Gemini can help. For this demo, we've created a simple interface, and with some clever prompting under the hood, we can really leverage Gemini's math, reasoning, and multimodal capabilities to learn a subject like physics. With Gemini, you can upload a photo of handwritten answers on a worksheet. Not only can Gemini solve these problems, but this is the amazing part. It can read the answers and understand what was right and what was wrong, and explain the concepts that need more clarification. So Gemini identified some mistakes with problems 1 and 3 here. Let's take a look at 3. Here, Gemini identifies that the formula was correct, but there was a mistake in calculating height. We can ask Gemini to explain in more details why the height is 50 meters instead of 6. I can ask Gemini to explain further. Here, Gemini explains the step-by-step details to solving the problem. Because of Gemini's ability to understand nuanced information and answer questions relating to complicated topics, it can give you a customized explanation of the subject you're trying to learn. And lastly, if you want to learn more, you can just ask. Gemini will provide personalized practice problems based on mistakes. Here I have a similar problem where I have to figure out the cat's speed, where the height of the ramp is double. Oh yeah, I knew that.
Now let's take a look at how Gemini finds and extracts data from scientific research papers.
A common problem scientists face is the need to find and use data extracted from the scientific literature. This is difficult because scientists need to search among thousands of scientific papers for key information and extract them by hand. It's a very common workflow and very time-consuming. In fact, some of our scientists at Google DeepMind face this very problem. They use Gemini to help with it because Gemini has an incredible understanding of science. Taylor will explain more.
So we were looking at this study from 2022. The authors had created a data set by reviewing tens of thousands of scientific papers in genetics. They found a few hundred papers that contained the relevant information, extracted it by hand, and collected it in a table. Studies like this can take a lot of time. We needed to update this data set with what's new over the last couple of years. But that's over 200,000 new open access papers added to this domain since 2021. We couldn't do this manually, so we asked Gemini to help us out. First, we needed to filter for relevant scientific papers. We wrote a prompt, just like this one, telling Gemini exactly what to look for. With its advanced reasoning capabilities, Gemini was able to distinguish between papers that were relevant to the study and those that weren't. For the relevant papers, we wrote a similar prompt, asking Gemini to read the paper and extract the key data for us. We could even ask Gemini to add annotations. This showed us exactly where in the paper Gemini found the information. We ran this at scale. And over a lunch break, Gemini read 200,000 papers for us, filtered it down to 250, and extracted their data. So now we have a refreshed version of this data set. But because Gemini is multimodal, not only can it reason about information from text, it can also reason about figures. So let me show you something really neat. With our refreshed data set, we can now ask Gemini to update a graph from the original study. We first gave Gemini a screenshot of this figure. Then we asked it to generate the code required to plot it. And by feeding this code our new data set, we get our updated figure. You can see that this figure now includes data up until 2023.
So Taylor used Gemini to search a large corpus of literature for relevant papers and extract key information from these papers, as well as update figures. Of course, these capabilities can help more than just biologists or even scientists. They extend naturally to any domain that is reliant on large datasets, such as law or finance. So that's what Gemini can make possible, and we are excited to see what you will create with Gemini.
So essentially now we're going to get into some of the details of Gemini's technical report, which is essentially just the deeper dive into the actual model, how it works, and some of the actual capabilities. So what we can see here is we can see the user's input image, and the user essentially takes a picture with their phone, and of course they use their voice to talk to Gemini, and then Gemini essentially responds. What this person is trying to do here, they are essentially trying to make an omelette. So they took a picture of the omelette. You can see that the model responds, crack the eggs into a bowl and whisk them. Then, of course, the person then goes and says, "Thank you for the instructions. I started making my omelette. Does it look ready now? It looks like it's almost ready. You can flip it over." And then the person asks, "Why is it not ready?" And then it responds, "It's not ready because the eggs are still runny." And then it says, "What about now? It looks like it's ready now. You can take it off the heat and serve it." So this is a simple interaction that you can see how AI is about to be embedded into what we do on a daily basis, definitely making a lot of tasks easier with the multimodal capabilities. So this is something that I find has a lot more applications than just large language models, which are mainly software based. When we have a model that is this capable in terms of its image recognition and being able to combine that, it presents for a really nice experience for the user. One thing that I did want to understand was I did want to understand exactly what the context length for Gemini exactly was. Here you can see that it tells us that the context length for Google Gemini is of course a 32 context length. So Gemini models are trained to handle very long sequences of data, specifically 32,768 tokens, which essentially enables them to utilize the context more effectively. The effectiveness of the models with long context lengths was tested using a synthetic retrieval test. This involves placing a key value pairs at the beginning of a long string of text, then checking if the model can accurately retrieve the value when given the key, even with a lot of intervening text. Now, what was also incredible about this was that it showed the correct value with 98% accuracy when queried across the full context length. Now, as the sequence position increases, meaning as you go further into the text, the NLL decreases, indicating that the model can effectively use the context information throughout the entire length of the text up to the full 32K token length. So in essence, this section is highlighting the model's advanced capability to handle and retrieve information from very long text, which is a significant improvement over models that could only handle much shorter text. Now here we have some more stuff on reasoning and code generation. Now this is going to look eerily similar to what we saw in GPT-4 before, so this is quite interesting. We have something that says create a web app called Opossum Search, and then essentially we were given it 5 instructions. Every time you make the search query, it should redirect you to a Google search with the same query but the word opossum before it. It should be visually similar to Google search. Instead of the Google logo, it should have a picture for the opossum for the internet, and it should be a single HTML file, no separate JS or CSS files. It should say powered by Google search in the footer. Then of course we can see that on the next slide here, this is exactly what we got. And of course, this is something that does work. Remember, this is being powered by their powerful Alpha Code 2, which does involve search and planning capabilities. Then of course, we have multimodal question answering. It says, do you know what this plant is? How do I best take care of it? And of course, we can see that it gives us a detailed answer on exactly what this plant is and how best to take care of this. Now, this does have a very nice capability in the sense that being able to identify exactly which plant is what and all the specifics is something that is going to help a lot of people out. Combined with the knowledge of millions of different plants, we can see exactly how good this model is going to be for various different use cases. Then of course we have interleaved image and text generation. So it says, please create a blog post about a trip to New York where a dog and his owner had lots of fun. Include a few pictures of the dog happily posing at different landmarks. So this is where we can see that this is something that is generating images and is able to follow the instructions of generating a blog post closely related to the text and showing us levels of consistency with the dog across all images. So I find something like this really, really effective because once again, it's showing us that when you combine that multimodal capability, we are going to have something that is far superior to previous language models. You can't actually do this in GPT-4 in terms of the consistency. So this is definitely a step up from what we've seen previously. Then of course, we have information seeking about objects, and we can see solving a puzzle using multimodal inputs. It recognizes the objects in these images and identifies a commonality that connects the two objects. Then of course we do have chart understanding and reasoning over data, and this is actually something that Google was really good at. I did test Bard yesterday and made a complete tutorial on how to use Bard, and when I did test it, it actually did really, really well at retrieving data from charts and then interpreting it into that. So it actually says, spot a data point that stands out in these charts and what that implicates. Then produce a detailed markdown table for all the data shown. Then we can see here that it shows us the exact data in this table. And it says that the data point that stands out is the United States landfill plastic waste, which is 73%. So it shows us that this definitely has some really, really advanced capabilities in terms of the multimodal chart understanding. Then, of course, we do have one of my favorite capabilities, and this is, of course, the video understanding. We can see that the user put in this question, how could this person improve their technique? Then, of course, we have Gemini saying that this soccer player needs to work on their ball striking mechanics. Their foot is not making good contact with the ball, which is causing the ball to fly up and away from the goal. They also need to work on their body positioning, and they should be leaning into the shot with their non-kicking leg in front of their kicking leg, and they should be following through with their kicking leg. The Gemini is actually completely multimodal, and this video was input, and this output that they gave was pretty stellar. So if you've ever played soccer or if you've ever played football in the UK, you'll know that exactly what they're saying is pretty true, and that technique that they're using is actually not accurate whatsoever. So I'm really, really excited to be getting to use Gemini and seeing exactly how good those video capabilities are. Now here we need to know and take a look at what is next for Google Gemini, because apparently this is only the beginning. So Hassabis says Google DeepMind is already looking into how Gemini might be combined with robotics to physically interact with the world. To become truly multimodal, you'd want to include touch and tactile feedback, he says. There's lots of promise with applying these sort of foundation type models to robotics, and we're exploring that heavily. So it seems like the future of humanoid robotics or some kind of robotics are going to be combined with some kind of foundation model in order to provide an ability for these large language models or AI systems to interact with the world in a new way, which definitely would be a very interesting thing because it's not something that we've seen done to a very high level just yet. In addition, what's crazy was that they did talk about next year. So this is an article from The Wired that I'll leave a link to in the description. And essentially the article reads, for AI agents to work dependably, the algorithms powering them need to be a lot smarter. OpenAI is working on a project dubbed QStar that is designed to improve the reasoning capabilities of AI models, perhaps using reinforcement learning, the technique at the heart of AlphaGo. Hassabis says his company is doing research along similar lines, which is something that we did talk about 6 months ago, where Hassabis actually did state that they are focusing on searching and planning. He additionally goes on to state that we have some of the world's best reinforcement learning experts who invented some of this stuff. And then it goes on to state advances from AlphaGo are hoped to help improve planning and reasoning in future models like the one today. Then he states, we've got some interesting innovations we're working on to bring to future versions of Gemini, and you'll see a lot of rapid advancements next year. Now, I really want to break this statement down because you can miss some of these key statements if you don't look into the words that he used. He said we've got interesting innovations and rapid advancements. So that's two key things. Number one is the innovations part. Now, innovations is a key word because he didn't say that we're going to make these models better. What he said is we're going to be doing innovations. And what that means is that we're likely to see something new and likely something that we've never seen before, which essentially makes next year a really fascinating year for anyone in AI because we're going to see a lot of different models and a lot of new techniques that we've never seen before. You have to remember what they've done with AlphaGo and previous models to truly understand the capabilities of Google DeepMind. And them also saying that you'll see a rapid advancements next year shows us that we definitely are in for a crazy 2024.